so name of the chapter is chemical kinetics. Chemical kinetics. This particular chapter is the branch of chemistry where mainly we deal with the speed of the reaction. Speed of the reaction, that is how fast a chemical reaction is taking place. We also call that term, speed is also called rate. Rate or speed of the reaction. That's the first thing. Okay, that chemical kinetics is the branch of chemistry where we deal with the speed or rate of the reaction. Not only that, we also deal with the mechanism of the reaction. Mechanism of the reaction means what? How the reaction is taking place. How? Now, whenever a chemical reaction is taking place, what happens? Certain bonds are broken, then certain new bonds are formed, and hence the reactants are converted into the products. Okay, so the mechanism also we study mainly in the chemical kinetics, but at our level, wherever we are studying the chemical kinetics, we are going to study mainly with speed or rate of the reaction. Okay, just a little bit of mechanism at the end we are going to study, but mainly we are going to study with the speed or rate of the reaction. Now, according to the speed or rate of the reaction, the chemical reactions can classified in three main types. The chemical reactions can be classified in three main types. One type we call very fast reaction. Very fast reaction. Very fast reaction means which happens or which takes place instantaneously. For example, suppose there are so many reactions. You have done so many reactions in the laboratory also which are very fast reaction. For example, suppose if you can remember, you have done it in lab also. If you take some sodium chloride solution, suppose some sodium chloride solution in test tube, and add some silver nitrate solution, as you add the silver nitrate, immediately you observe that there is white precipitate that is formed, right? So some chemical reaction is taking place and that takes place instantaneously. It is happening very, very fast. That type of chemical reactions are categorized under very fast reaction. So the example I had given, you can write down that example. What is that? Sodium chloride plus silver nitrate produces silver chloride. Silver chloride is precipitated, you know, and what else? Sodium nitrate. Sodium nitrate is going where? Sodium nitrate is going in the solution. Okay, so this is an example of what? This is an example of the very fast reaction. The second category is very slow reaction. Very slow reaction. Okay, very slow reaction means which takes which takes maybe months, years to come to be completed. Completed means to come in equilibrium. Okay, for example, the most common example I am telling is that rusting of iron. Rusting of iron, you know that rusting of iron takes place years. Rusting of iron, that takes place years to come to equilibrium. You know, rusting of iron takes years to come to equilibrium. So that's a very slow type of reaction, very, very slow reaction. And the third type of reaction is a moderately slow reaction. That is called moderately slow reaction. Moderately slow reactions means what? Which are taking place or which are coming at equilibrium within few minutes or within few hours. Okay, so that we can observe, we can just experiment the rate of these particular equations. Okay, which are neither very fast nor very slow. Which are moderately slow means it is happening means it is coming to equilibrium within few minutes or few hours. Okay, just few minutes or few hours it takes to come to equilibrium. That is why they are called moderately slow reaction. For example, just one example I am writing. There are so many of this. Okay, just one example I am writing. For example, suppose what is that called? Hydrolysis of sucrose. Hydrolysis of sucrose. So what is that? C12H22O11, that is sucrose, plus if we add water, it is converted into C6H12O6 plus C6H12O6. Just one example I am writing. It's nothing. It is both the C6H12O6. Why I wrote? You know, one of them, you are all biology students, I know. So one of them is glucose and another one is fructose. One of them is glucose and another one is fructose. Okay. So this particular reaction is moderately slow reaction. Moderately slow reaction. Okay. Now, very fast reaction. It's very difficult to study the kinetics of very fast reaction because it happens in nanoseconds. It happens in nanoseconds. So it's really tough to understand, or really tough to study, I should say, the speed of these reactions. So which we cannot do at this particular level. At this particular level, that much of mathematical thing we don't know. If you further study with chemistry, obviously in masters, you are going to do this, where nanoseconds are actually required for the very first reaction. So certainly this is not in our syllabus. Okay. Very slow reaction which takes place years to be completed or years to come to equilibrium. Okay, it's useless to study. Suppose the rusting of iron is taking place in 100 years or 101 years, it does not matter to us. It hardly matters. It hardly matters that whether it is happening, the study of this is hardly matters that whether it is happening 100 years or 101 years or 105 years. So this also we are certainly not studying. We are mainly studying what? We are mainly studying the moderately slow reaction. Okay, the speed of the moderately slow reaction. Fine. So that is the first thing of chemical kinetics. That what is chemical kinetics? Branch of science or branch of chemistry, you can say, which deals with the speed of the reaction, or we also call it rate of the reaction. Speed or rate of the reaction. Clear? Now, according to the speed or rate of the reaction, this can be classified. This chemical reactions can be classified in three types. What are the three types? The first type is very fast reaction. Second type is very slow reaction, and third type is moderately slow reaction. Very fast reaction takes place instantaneously within nanoseconds. Very slow reactions takes years to be completed. Okay, and the moderately slow reaction takes minutes or hours to be completed. Fine. So very fast reactions useless to it's very tough to study. Okay, because it happens in nanoseconds, so the calculation part of it is very complicated, the mathematical part is very complicated, so we can't study at all level. Very slow reaction is useless to study. There is no use of studying the very slow reaction, that whether it is happening at 101 years or 105 years or 200 years, it does not matter to us. It's useless to study that particular thing. So what we are going to study? We are going to study the moderately slow reaction. Okay. Now, okay, fine. So that is the basic thing we understood. Now we have to understand that what is speed? Speed hota kya hai? What is speed? What is rate? Yes. What is? Please mute yourself. What is rate? Okay. What is rate? Rate is what is rate? The rate is that what is happening. Suppose, let us just take an example. Suppose I am taking the simplest possible example, that 1 mole of reactant is converted into 1 mole of product. 1 mole of reactant is converted into 1 mole of product. R is converted into P. Okay, this reaction is happening. The R is converted into P. Okay. Now when R is converted into P, suppose initially at time t equal to 0, when time t equal to 0, we have taken some amount of R. We have taken some amount of R. Okay. Now as the reaction goes on, after certain time, suppose after 5 seconds, what I will see? After 5 seconds, when t is equal to 5 seconds, what I will see, that the amount of R or the concentration of R will decrease little bit, because that will undergo the reaction. So this is suppose concentration R, and this is concentration, suppose this is R1, this is concentration R2, okay, and some amount of product will be formed. Okay, here there was no product, now some product will be formed. If I go after certain time also, then also certain amount of reactant will decrease, a certain amount of product will increase. So what happens with time? The amount of this is very simple logic, all of you know this. The concentration of the reactants decreases and concentration of the product increases. Till when? Till when this happen? It happens till the equilibrium is reached. Okay, till the equilibrium is reached. Okay, so with time the concentration of the reactant is decreasing and the concentration of the product is increasing. Now if we just try to plot it graphically, see, I'm just trying to plot it graphically. Concentration of reactant, here we are plotting, and here we are plotting time. Here in this direction we are plotting time. Now let at time t is equal to 0, the concentration of the reactant is this much. This much is the concentration of the reactant. With time increases, the concentration of the reactant will decrease, and one time will come when the concentration of the reactant will become equal. What is that time? That is nothing but equilibrium. So the variation is certainly not uniform. It's not that it is varying uniformly. It's varying non-uniformly. So the nature of the graph will be like this. It is decreasing non-uniformly, and one time will come when it will become constant. After certain time it will become constant. So this is the variation of what? This is the variation of concentration of R with time. And how the concentration of the product will vary with time? Please understand it. If I just plot concentration of product, how it will vary with time? Concentration of a product at time t is equal to 0, there was no product. At time t is equal to 0, the product was 0, the concentration of the product was 0. With time increases, the concentration of the product will also increase till when? Till the equilibrium reaches. One time will come when the concentration of the product will remain same, or will become constant. The equilibrium will reach, and that is how the concentration of the product is varying with time. So it is also not varying uniformly. So how it is varying? Can I draw the graph like this? It was 0, now it is increasing non-uniformly, and after certain time it will become constant. It will become constant. Okay, so that is the variation of the reactant and product with time. Fine. Now what is speed? What is speed? Again, before going to the speed of the reaction, let me know that I know you know it. Okay, so just a little bit brushing up of the speed factor. Suppose normal speed. Okay, suppose this is my home, and this is my school. This is my school. Okay, I go every day from home to school, and the distance between the home and the school is, suppose it is actually 8 kilometers, so I am writing 8 kilometers. Okay, the distance between my home or from my home to my school is 8 kilometers, so I am writing 8 kilometers. Okay, now I take, suppose 8 minutes time. 8 minutes time to reach to school in the morning. 8 minutes time to reach to school in the morning. Now if I ask you what is my speed? What is my speed in going to school? So obviously you will be saying that, sir, 8 kilometer per 8 minutes. That means 1 kilometer per minute. 1 kilometer per minute is my speed. Fine. 1 kilometer in 1 minute I am moving 1 kilometer. But the question is that, so if I ask you that what is my speed in the speedometer, what should be my speed? I mean what is the, generally we express it by kilometer per hour. So if I want to tell you that express it in kilometer per hour, you can very easily convert that, and it will be actually 60 kilometer per hour. 60 kilometer per hour. Okay, 60 kilometer per hour. Does it mean that I am moving from my home to my school, always I am moving with 60 kilometers per hour? Certainly not. Certainly not. So whatever speed you told, whatever speed this 60 kilometers per hour is you told, you talked about the average speed, right? You talked about my average speed. It is not that my speedometer was always at 60 kilometers per hour. Sometimes it might be at 100 kilometers, sometimes it might be at 20 kilometers per hour. Okay, but the average speed is 60 kilometers per hour. Okay, so that is what is the average speed. Now if I ask you, while going to school, I have to cross 2 flyovers. I have to cross 2 flyovers. And the flyovers are very empty while going, especially while going, because morning time when I am going, the flyovers are completely empty. So suppose this is the flyover, when I am at the top of the flyover, what is my speed? At that particular time, today I am going to school, what is my speed? That particular speed, to say that particular speed, you cannot say 60 kilometer, you cannot say 80 kilometer, you cannot say 90 kilometer, 100 kilometer, you cannot say that until and unless you are sitting beside me and you are watching my speedometer. Okay, so you are watching my speedometer at that particular moment, and suppose I am moving at that time at 100 kilometer per hour. So you will say, sir, your speed at that particular moment is 100 kilometer per hour. Okay, this speed at a particular moment is called instantaneous speed. Instantaneous speed. Okay, so you understood what is the difference between the average speed and instantaneous speed. So average speed is what? Average speed is calculated within a span of time. Within a span of time. Okay, from this much second to this much second, or from this much minute to this much minute, or from this much hour to this much hour. Okay, within a span of time, whatever is the speed, that is called the average speed. Okay, but at a particular moment, whatever is the speed, that is called instantaneous speed. Exactly the same, since it is non-uniform for the chemical reactions, exactly the same is applicable for the chemical reactions also. So chemical reactions can be expressed by the average speed as well as the instantaneous speed. So you just understand it is nothing, I am just telling it very simply. Suppose we started with some reactant and it's converted into product, I am still in that particular reaction. Okay, suppose at time t is equal to, we are observing that how the reactants, we are just observing the reactant, suppose at this moment. So we are observing that the reactant at t is equal to 5 seconds. After 5 seconds, suppose the concentration of the R, R1, I am writing T1 equal to 5 seconds, that means first time interval is 5 seconds. The concentration of R you observed equal to 100, whatever is the unit you observed equal to 100. Fine. At time T2, then after 10 seconds, you observe the concentration of R. What will happen to concentration of the reactant? It will decrease with time. We know that it will decrease with time. So from 100, suppose it has become 70. Suppose from 100 it has become 70. Okay. Now I asked you that what is the speed of it. Obviously now we are going to find out the speed within a span of time from 5 seconds to 10 seconds. So what should be the speed of it? See, it's very simple. What should be the speed of it? It's the change in concentration divided by change in time. How much concentration is changed per unit time? That is the speed of it. Now, one thing, be very careful, I am telling it. I don't know whether I told it or not earlier. That change, whenever I am using the word change means final minus initial. Never do it initial minus final. Change is always final minus initial, the final value minus initial value. So what did I say? What is the speed or rate? I am writing rate or speed, and obviously we are talking of average speed. Average speed. Why average speed? Because we are calculating it within a span of time. Should be equal to change in concentration. Change in concentration is how much? I am first writing in normally concentration R2 minus concentration R1. I told final minus initial. Final is R2, initial is R1, divided by change in time. Change in time is what? T2 minus T1. Now if I just write this much, and if you just put the value, what we are going to get? We are going to get 70 minus 100 divided by how much was the time? 10 minus 5. Okay, so that is equal to how much you are going to get? 70 minus 100 means minus 30. Minus 30 divided by 10 minus 5 is 5. So minus 30 by 5 means you will get it as minus 6, right? The speed you will get it as minus 6. But can the speed be minus? The speed cannot be negative. Okay, the speed of something cannot be negative. So what we express when we are expressing in terms of reactant, the average rate we are expressing by putting a negative sign beforehand. Okay, so the rate average is nothing but minus change in concentration by change in time. change in concentration by change in time. So a minus sign is beforehand there. So a minus sign is beforehand there. So that is equal to 6. Okay. Why this minus sign is there? What is the significance of this negative sign? The significance of this negative sign is that the concentration of the reactant is decreasing with time, and that is why to make the speed positive we are putting the negative sign. Since the concentration of the reactant is decreasing with time, so we are putting it what? We are putting a negative sign beforehand. The same expression can be written as, you know it already, concentration of R2 minus concentration of R1, that is change in concentration of reactant. Obviously there is a negative sign. Change in concentration of reactant, we write it by delta concentration R, and change in concentration of time is written as delta T. T here should be small because time is expressed as small t. Okay. Now the same rate, if we want to express in terms of product, I will come back to this. I'll come back to the graphs. That is why I'm not rubbing the graphs. Okay. So I'm writing over here only. Now same thing. Suppose after T1 equal to 5 seconds, the concentration of concentration of the product is equal to 70. The concentration of the product is equal to 70. P1 equal to 70. And at T2 is equal to 10 seconds, means when the time increases, the product's concentration will increase because more product will be formed. Let the concentration of the product is 100. Okay. So what is the change in concentration of the product, and what is the change in time? So change in concentration of the product divided by change in time is the rate of this reaction. So rate average for this particular case, can I write it as concentration P2 minus concentration P1, that is change in concentration of the product divided by change in time? Yes, that is equal to, now the concentration of the product is greater. Okay, after time t, t is equal to 10, so it is 100 minus 70 divided by 10 minus 5. Okay, so that should be equal to how much? That should be equal to 6. So is any negative sign required in case of concentration of the product? No. Why not? Because the concentration of the product is increasing with the increasing time. Hope it is clear that the concentration of the reactant term, why are we writing negative sign, and why in terms of concentration of product we are calculating the rate average, we are writing it in terms of positive sign. Okay, so why? What is the significance of the negative sign? What is the significance of the positive sign? Okay, and one more thing I must tell you is that now see here I had chosen such value so that the rate average you are calculating in terms of concentration product or concentration reactant, it's same, it has to be same, because finally we are calculating only the rate of the reaction. Doesn't matter whether you are calculating it in terms of reactant or in terms of product, it has to be same. Means it's like that, the case is like that. Just it had come in my mind, so I'm just telling it. Don't write all these nonsense things anywhere. Okay, so suppose you are traveling with me in the same car. Okay, if somebody asks what is my speed, suppose my speed is 50 km/h, and if the same person asks you what is your speed obviously won't be different because we are traveling in the same car. Okay, exactly like that, the reaction is happening with the same reactant. The reactant and product are there for the reaction only. So if I ask you what is the reaction in terms of reactant, whatever is the speed, the same will be in terms of product only. Okay, so can we write down this equation finally, that rate average should be equal to minus delta R by delta T. That should be equal to delta concentration P divided by delta T. Only thing you must know, or you must understand, that why the sign over here is negative and why the sign over here is positive. Sign over reactant side is negative because of what? Sign over reactant side is negative because the concentration of the reactant is decreasing and with time, and sign is positive in case of what is that called, in case of product, because the concentration of the product is increasing with the increase in time. Is it clear? Now the next is instantaneous rate. Instantaneous rate. What is instantaneous rate? I told at a particular moment what is the speed. Before going to instantaneous rate normally means mathematically, first let us understand it graphically. Okay. Now suppose this graph is very clear that concentration R is varying with temperature, with time like this. Concentration of P is varying with time like this. Okay. Now if I ask you that what is the average rate, you just find out the average rate. You have a graph paper, you have the values over here. So I just ask you calculate the rate of the reaction, average rate of the reaction, in between time span 10 to 20. In between time span 10 to 20, you calculate the rate of average reaction. I mean average rate of reaction in the time span 10 to 20. Okay. So what we know? Suppose this is 10, this is 10, this is 20. This is time 10 seconds, that is 20 seconds. So from the graph, what we are going to do, suppose we are doing in terms of reactant. What we are going to do? We are going to take the concentration of the reactant. So this is the concentration of the reactant at time 10. Fine. What is the concentration of the reactant at time 20? This is the concentration of the reactant at time 20. This much is the concentration. This much is the concentration. At time t, at time 10, this is the concentration. This much is the concentration. Suppose that is equal to 10. Suppose at time 10 the concentration is 10. At time 20 the concentration is 5. Okay, so what is the change in it? 5 minus 10 divided by what is the change in time? 20 minus 10, 20 minus 10. But since we are doing it in terms of a reactant, there must be a negative sign over here. So you can very easily calculate the average rate of the reaction from the graph. Same we can do for the product also. Exactly the same we can do for the product also. We have to choose the time difference. Then we have to measure the concentration of the products. If we measure the concentration of the products, obviously we can find out the rate very easily. That's the average rate. So we don't have any problem with the average rate. Now I told that find out the rate or the speed of the reaction at suppose 15 seconds. At 15 seconds. 15 seconds, what is the speed of the reaction? So this is 15 seconds. This is 15 seconds. And at 15 seconds, this is the concentration. This is the concentration of the reactant. And same way for the 15 seconds, this is the concentration of the product. This is the concentration of the product. So we know the concentration of the reactant or the concentration of the product at 15 seconds. Fine. Fine. Absolutely fine. Now, how can we find out the instantaneous rate? See, tell me just one thing. It's a mathematical thing. I know one section don't have mathematics, so I'm little bit reluctant to that particular section. So I'm trying to explain you in such a way so that you also should understand that why are we doing this. Okay, why are we doing this? And little bit of basic of mathematics only we have to know. Okay. So what is this? Now if I ask you that what is the rate of the reaction at 15 seconds, and then after asking this, if I ask you what is the initial time, you will say sir 15 seconds. Okay. And if I ask you what is the final time, you will say sir 15 seconds. Okay. Because I told that calculate the rate of the reaction at 15 seconds. At 15 seconds. Exactly at 15 seconds. What is the speed? Fine. So initial time is also 15, final time is also 15. Fine. So what is the change in time? What is the change in time? Delta T should be equal to 0. Now what is rate expression I had written over here? Delta T is at the denominator. Delta T is at the denominator in both the cases, right? Doesn't matter whether you are doing it in terms of reactant or in terms of product. But if the value of delta T becomes 0, this does not have any physical significance. That is indefinite we call it. Okay, it does not have any physical significance if the value of delta T denominator equal to 0. So mathematically we cannot make delta T 0. What we do is that we make delta T is approaching 0, is almost equal to 0, So instantaneous rate can be mathematically expressed as, see, it's very simple again. Instantaneous rate is mathematically expressed as rate instantaneous is equal to, in terms of reactant, obviously negative sign. Why negative sign? You know, because the concentration of the reactant is decreasing. Minus delta concentration R divided by delta T, but the condition is what? The condition is delta T is approaching 0. Okay? This particular figure, this particular expression, I know those who have mathematics, you must know it. This particular expression is nothing but, this is nothing but the differentiation expression. This is nothing but the differentiation expression. That is what is known as differentiation. So this one, we write it like this. We can also write it equal to minus, obviously minus sign is there, d concentration R dt. This is not division, okay, this is differentiation. We say it, if you want to say it, you can say it as a d dt of concentration R. But why the negative sign is there? The negative sign is there because the concentration of the reactant is decreasing. Okay, that is dr dt. Same way, instantaneous rate can be expressed in terms of product as plus, obviously plus now, plus d concentration P dt. Okay, plus d concentration P dt. Now the same thing, same instantaneous rate, how can we get it from the graph? I told 15 seconds you have to find out the instantaneous rate. Okay, 15 seconds you have to find out the instantaneous rate in terms of reactant or in terms of product. How can we find it out? At 15 seconds, whatever is the concentration in the graph, we have to draw, this is just pure mathematics, that is why I am telling it. Okay, we have to draw a tangent. To it. At 15 seconds, whatever is the concentration of the product, we have to draw a tangent to it. Only one tangent is possible, and that tangent we have drawn. Since the tangent is a straight line, we have to get the slope of it. Graphically. You know what is slope? Slope means perpendicular by base, that is tan theta. Slope means perpendicular, so we have to draw a right angle triangle. By taking this as hypotenuse, we are just going to measure the perpendicular and the base, okay, and we will just divide the perpendicular by base, and we are going to get the slope of it. The slope of it is nothing but dr dt or dp dt. Okay, obviously, as I told you that in the previous class also, in the previous chapter also, that straight line has got two types of slope. One is positive slope, one is negative slope. What is positive slope? If the value of x increases with the increase of y, that means this is positive slope. So in terms of concentration of P, the slope is positive, and hence the term over here is positive. And if it is opposite, if the value of x decreases with the value of y, or if the value of y decreases with the value of x, okay, then the slope of the curve is called negative. So in this case, the slope is negative, and that is why in terms of reactant, the concentration, the rate instantaneous term is coming as negative. Whatever we discussed, we discussed it for the very simple or the simplest possible reaction. And that simplest possible reaction is 1 mole of reactant is converted into 1 mole of product. Okay, tomorrow we are going to do it further. Okay.